Right into it. Project 3 is on file system. Step 1, develop a library to read a WAD file. Step 2, implement user space daemon to access a file structure. And 3, test the implementation by navigating the file system and examining contents. So the first thing I did right here, I defined struct entry with name, path, offset, length. Also define how to create one with the WAD class functions. GetMagic, this function returns the magic string associated with the WAD. GetSize iterates through the entries and locates entry with the correct path, checks for content, and returns the length of the size. So I'll show you that. Here we are. This is how we create one of the entries. This is how we get magic, get size, checks for the content. So let me show you is content. We iterate through all the entries. If the entry at this path is not a directory, cool, return that. Similar to is directory, except we check whether this is the root path, and we check when we pass this from fuse, whether at the end has this forward slash, and if not, we add it. And it does the same thing, but in reverse. So again, is content iterates through, returns true if the entry is not a directory. Is directory works similarly, does some edge case. Get directory takes a path and a vector of strings and fills a vector with the names of the immediate children of the directory. If the path does not represent the directory, returns -1. So get directory, like I said, the same thing with the path. We iterate through. If it is not a directory, then return -1. Continue if it is. We add all the names of the children. Update count. So get contents takes a path, a buffer, and a length and an offset, and copies the content into the buffer, starting from the offset up to the length. If the path does not represent a file, it returns -1. So similar, we check for the content, iterate through, the path is correct, and here we do a check for the offset and length exceeding the entry size. We just add what's left over, then copy the buffer. And load WAD. This one took me the longest, but it's how the WAD dump file works, so it was important to get right. This one opens a file given a path, reads its data, and assigns them to a WAD object, seeks the offset position in the file, and for each descriptor reads its name, length, and offset, and creates an entry. Entries are organized by the start and end namespace markers. Finally, it returns a pointer to the WAD object. So this is where I seek, I open the file, I create the first entry, the end parent, I create the parent stack, I push to it, iterate through each num descriptor. Is it a start namespace marker? Okay, this is how we create the entry. We update the parent. There's an end, similar, pop that. The substring checks, map marker, first data found. And yeah, not my best code, but it works and have the job done. And this is the end of it. So let me show you how we use it. SH test. There it should have ran with sample WAD, and so we see mounter contains this guy. We can check it out. The cake, what is it? It's a lie. So we can cd into mounter and even check. Cool, that's working. And that's also working with our WADFS. So if we go into WADFS real quick, we define the 3 functions we have to overload: get attribute, read, and read dir. Put in our callbacks. It's pretty simple. If it's content, sets the permissions, and if it's directory, sets the right permissions, returns 0 for both. Read dir, checks if it's directory, adds it to the vector strings, fills it in the buffer, and the read callback. Get content. In the main, this takes care of the if we pass in any args or anything like that. So into this. Because it uses the read from our guy, and look, it's there. And it's all good. My goodness.